There's a second prediction that I asked you to make, the one with the compressed spring. I like doing that. The one with the compressed spring, we are adding on an extra mass to, like so. And I was asking you to predict what do you think will happen to the velocities in this situation. So, what do you think is going to happen to the velocity of this object here with the extra mass? Smaller velocity because of smaller. And what about this guy here? This one you're predicting will go slower. This one will go faster. Okay, let's give it a try. Here we go. I think it was a little bit faster. But the important thing is that in this situation here, what do we know about the size of the two forces? Same. Now, a lot of people who haven't taken grade 11 physics, very, very sad situation, they would say, oh, no. This one, of course, experiences a force. It goes shooting off really fast. But they would say, but this one, it doesn't experience a force. Right? It's the one doing the pushing, right? This one is just sitting there minding its own business. How can it possibly push on the one with the spring? Well, a lot of people would say something like that. So let's watch very carefully. So watch this one very carefully. Is there any evidence that this one experienced a force?
Yes.
So we saw it accelerate. Started at rest, then was moving in that direction. So this does experience a force, even though this object here was just kind of sitting there, minding its own business. So I'm saying this to help emphasize just how important and deep the idea of an interaction is. So anytime there's any kind of interaction, the two objects will be exerting equal size forces on one another, no matter what the situation is. No matter who has the spring, who's sitting around, who is very massive, who is very small. This is a very fundamental idea for how our universe works.